Today we're going to talk about aqueous systems in electrolysis, and let's look at a simple system to start with. Let's look at sodium chloride aqueous. Okay, now obviously to make sodium chloride aqueous you dissolve sodium chloride in water, and the sodium ions break apart from the crystal lattice, and the chloride ions do as well. So we have sodium ions and chloride ions, but we also have water molecules. Now these water molecules will affect the outcome of the electrolysis. So aqueous systems are inherently more complicated than molten systems. Let's have a look at what happens to a water molecule. Okay, a water molecule will split up into H plus ions and OH minus ions, okay, in this system. Okay, now it doesn't do it much, hence the equilibrium sign, but these ions will be present in the electrolysis, H plus ions and OH minus ions. So the ions we have in the electrolysis are sodium ions and chloride ions from the compound, and hydrogen ions and hydroxide ions from the water. Now in any aqueous system these two ions will always be present because of the water. Okay, so now let's try and draw a little picture here with the electrodes. Okay, now you'll have sodium ions and chloride ions. Okay, this is my small setup, and you'll have H plus ions and you'll have OH minus ions from the water. Now, I know the picture's not very good, but I'll draw a better one in a minute. Now, this is the positive and this is the negative of the cell. So this is the anode, this side is the anode, and this side is the cathode. Now in this case, the sodium ions will go to the cathode, but so will the hydrogen ions from the water. The chloride ions will go to the anode, but so will the hydroxide ion from the water. Okay, so in this type of electrolysis with aqueous systems, the anode, we have two types of anions. Okay, and they are the chloride ion and the hydroxide ion. And we have two types of cation. We have the sodium ion and the hydrogen ion. Now, in aqueous systems, you'll always get the OH minus ion going to the going to the anode, and you'll always have the hydrogen ion going to the cathode. So these guys will be present in all aqueous electrolyses. Okay, the ions from the compound will be there as well. Alright, now obviously the trick is to say which one of these two will be discharged and which one of these two will be discharged, so we can find out what the products of the electrolysis are. Now there are rules for discharge. Okay, and this tells us what we're likely to get at the cathodes and we're likely to get at the anode. Okay, now the rule at the cathode is very simple. It's the ion that is discharged is the least reactive of the pair. Now bearing in mind hydrogen will always be there in aqueous systems, and for the anode hydroxides will always be there as well. Now for the cathode rule, okay, it's a choice in this case anyway between the sodium ion and the hydrogen ion. Now which one of these two is least reactive? It's the hydrogen ion. Okay, in other words what I'm trying to say is hydrogen is less reactive than sodium, so it's the hydrogen ion will be converted back to hydrogen atoms more easily than sodium can be. Okay, so it's very simple. Rule at the cathode is the least reactive will get discharged. Okay, so in this case it's the hydrogen, and now we have to draw the discharge for the hydrogen ion equation, which is this, and don't forget it's diatomic, so you have to have two of those, and two of those gives H2 gas. So we'll get hydrogen at the cathode. Now the rule at the anode It's a very simple rule as well. This one will always be present, and this is the changeable one, the other anion. So in this case, what we say is if there is a group 7 present, if a group 7 is present, okay, which are called halide ions, by the way. If there is a halide ion present, it gets discharged. If not, the hydroxide gets discharged. Now in this case there is a group 7 present, and it's a chloride ion, so that will get discharged. So now we have to do the discharge of a chloride ion, which is Cl-. It becomes the atom and its electron, but again it's diatomic, so we put a 2 there. We need 2 of those and 2 of those. So what we have at the cathode is hydrogen is discharged because it's lower in the reactivity series. It's lower than the metal. And at the anode there is a halide present, so the chloride is discharged. So that goes. So in this particular case, hydrogen forms at the cathode and chlorine forms at the anode. Let's have a look at what we originally had in our solution. We had sodium ions and chloride ions from the compound. We had hydrogen ions and hydroxide ions from the water. Now the hydrogen ions slowly get discharged and the chloride ions slowly gets discharged. So what's the solution slowly turning into? Sodium hydroxide. And that could be described as a third product of the electrolysis. Chlorine, hydrogen, and the solution slowly turns into sodium hydroxide. Okay.